We're going to take a look at linear functions and specifically slope-intercept form. So the slope of a non-vertical line is the ratio of the vertical change over the corresponding horizontal change. So that's the change in the y values over the change in the x values. And that's where we get the y2 minus y1 over x2 minus x1. It's telling me the rate of change of my line. How fast is the y values changing with respect to the x values? So finding the slope between 2 points, we just go ahead and assign our x1, y1, and our x2, y2. I could have swapped these around. It's not going to make a difference. You'll always get the same answer. So plugging this in, I get 4 minus 7 over negative 2 minus negative 3. So on the top, I'm going to get negative 3. And on the bottom, negative 2 minus negative 3 is like saying negative 2 plus 3. So I'm going to get a positive 1. So my slope is negative 3. So we only write negative 3, but we know that that means that the change in y is negative 3 and the change in x is just 1. Now over here, the same thing. So assign my x1, y1, x2, y2. Go ahead and plug into the slope formula, and we're going to get 1 minus 1 over negative 4 minus 3. So 0 over negative 7, which will just reduce to 0. So the slope is 0, which means I have no change in y whenever I'm changing my values of x. So here are the different types of slopes of a line that I can have. I can have a positive slope line, which raises from the left to the right, a negative slope line, which falls from the left to the right, a zero slope line, which is a horizontal line, and then an undefined slope, which is going to be a vertical line. So mathematically, what this is going to look like, obviously positive slope is just going to be some positive number. Negative slope is going to be a negative number. Zero slope, you're going to get a 0 over some number, which will reduce to just 0. And undefined is going to be a number over 0. So anytime you have 0 in the denominator, that is not allowed, and we say that that is an undefined slope, and it's going to be a vertical line. The term no slope is not a mathematical phrase, so please do not say no slope. There is always a slope. It's either zero slope or undefined slope. A linear function is a function whose graph is a line. Now you can represent a linear function in many different forms, such as this form right here, y equals 6x minus 4, which is called slope-intercept form. Now the solution of a linear equation is any ordered pair x and y that make the equation true. So for example, here in this graph, the coordinate 0, 1 would be a solution to this linear equation because it exists on the line. Actually, there's infinitely many solutions because there's infinitely many points that exist on this line. An intercept is the points where the line crosses the axes. So whether we're crossing the y-axis or the x-axis, we have a y-intercept when we cross the y-axis and an x-intercept when we cross the x-axis. Now on the y-axis, all of the x-coordinates have a coordinate of 0. Therefore, this coordinate is going to be in the form 0, comma, some number because x is always 0. The x-intercept, well, all the coordinates on the x-axis have a y-coordinate of 0, so the x-intercept is going to have a y-coordinate of 0, so it's going to be in the form a number, comma, 0. So slope-intercept form is y equals mx plus b, where m is going to be representing our slope here, and b is going to be our y-intercept. So be careful here. The y-intercept does take the sign that is in front of it, and it's always 0, comma, whatever this number is, because remember the y-intercept is actually a coordinate, so it must have an x and a y coordinate, and the y coordinate comes from this b term. So I want to write the equation of a line below in slope-intercept form given the slope and the y-intercept. Well, slope-intercept form is y equals mx plus b. So here I have my m, and then here I have my b. So I'm just going to go ahead and plug those in. I get 1/5 x plus, and I have a negative 3 for my b. So to reduce that, I'm going to go ahead and get rid of that plus minus and just have negative 3. So here is the line that has a slope of 1/5 and a y-intercept of -3. So what's the equation of this line? Well, looking at this line, I can see that I have a y-intercept here. My y-intercept is going to be at 0, -3. And I can check my slope. Remember, your slope tells you your rate of change. So how are you changing in your y direction for every x direction? So my slope here is going to be, well, I go up 1 and to the left 2. So up 1 and to the left 2. Left means a negative direction, so that's over 2. So my slope is going to be 1 over -2. So my slope is -1/2, and my y-intercept is 0, -3. So the equation here is going to be y equals, and then I put my slope, x plus b. Now b is -3. Notice here I have a negative slope and my line is slanted from the left and falling to the right. So the slope of a line should stay constant regardless of which points on the line you are referring to. So that means between any 2 points on the line, the slope should stay the same. So this is the same line we just looked at. We found that the slope was -1/2 whenever we moved between this point here, the y-intercept, to this point here, -2, -2. So if I'm looking at the x-intercept, -6, 0, we want to know, am I going to get the same slope as I did before, now moving from this point down to my y-intercept? So I am going to fall 3. I'm going to go in the negative y direction 3. So that's going to be -3. And then I'm going to run 1, 2, 3, 4, 5, 6, and I'm going in the positive x direction, so that's +6. And if I reduce that, I still get -1/2. So it doesn't matter which 2 points you are moving between on a line, the slope should always stay constant. So we want to rewrite the equation in slope-intercept form. So I have a little bit of work to do. I need to move things around. I want to be in the form y equals mx plus b, which means I need to isolate my y term. So isolating my y term, I'm going to first move the 5x over to the other side. So subtract 5x from each side. So I get -4y equals -5x plus 16. I'm going to write it like this because I know I'm going to be mx plus b, so might as well put the x term first. So now I need to go ahead and get rid of the term that is connected to my y, which is a -4. So dividing every single term by -4. So everything needs to be divided by -4. Y equals, now I'm going to get -5 divided by -4, which is a +5/4. Positive 16 divided by -4, which is going to be a -4. So here is my line. I have a slope of 5/4 and a y-intercept of -4. So my slope is 5/4 and my y-intercept is going to be 0, -4. Remember, your y-intercept is always a coordinate. Here is Ms. Fuller's guide to graphing an A++ line. Whenever you're given an equation in slope-intercept form, y equals mx plus b, you're going to identify your y-intercept, so that's 0, b. You're going to go to that point on your graph and plot your coordinate. Now, from your y-intercept, you are going to use your slope to get to another point on your line. And you can repeat this process as many times as you need until you can see the general shape of the graph and you fill the coordinate plane. Now you're going to draw a line through these points and you're going to make sure that you have everything labeled. So you need arrows on the end of your line, your axes should be labeled, your line should be labeled, so put the name of your line on there, and then you also need to label the points. So here I have the line -2x plus y equals 1. So in order to put it in slope-intercept form, I'm going to move the 2x over. So I have y equals +2x plus 1. So my slope is going to be 2, and my y-intercept is going to be 0, +1. So plotting my y-intercept, 0, 1. using my slope of 2 to get to another point on my line. So whenever I have 2, I know that's 2 over 1. I'm going to rise 2 and run 1, rise 2 and run 1, rise 2 and run 1. I'm going to keep repeating this until I have enough points on my line to see the shape of the graph. Now I'm going to draw a line through these points. I'm going to include my arrows, and I need to have at least 2 other points labeled on this graph. So this is 1, 3, and this is -1, -1. Label my axes, y and x, and then label the name of my line, which is y equals 2x plus 1. And this is an A++ graph. Y equals -2. Now, as you can see, there is no x value here, which means this is not my slope. So y equals -2, what does that mean? Well, that means that for every single coordinate on the graph, it has a y value of -2. So every single coordinate on the graph, it's going to have a y value of -2. So every x value on this graph has a y value of -2. So it's going to be this horizontal line, y equals -2. So this line will have 0 slope, because to get from one point to the other, I have no change in y. So it's always 0 over some number, 0 over some number. So there's no change in y. Labeling a few points on this graph, this is 0, -2. Let's label this guy over here. This is 4, -2. And then I'll do -4, -2. Notice that all of these coordinates have a y value of -2. Labeling my axes. And I check I have my arrows, so I am good to go. X minus 5 equals 0. Now, as you can tell, I have no y value now. So solving for x, I get x equals 5. So what does this mean? This means every single coordinate has a x value of 5. So let's go to 5 on my x-axis. Every single coordinate on this line is going to have an x value of 5. So it's going to be a vertical line at x equals 5. So graphing this line, including my arrows, let's plot a few points. My x-intercept here is going to be 5, 0. Let's plot this point 5, 3. And I'll label a point down here. Let's label 5, -3. Labeling my axes here. I have the y and the x. And then making sure to label my line. This is x equals 5. So as you can see, every single x coordinate on this graph is 5, because this line will have an x coordinate of 5 for every single point. And the slope of this line is going to be undefined. Because as I change my y, I am not changing my x. So I'm going to get some number over 0, which is undefined. Go ahead and try these out and put these in your notes. And give graphing this line a try as well.